Hello everyone, I am Dr. Abha Kumari, Assistant Professor, Nirmala College. Today our topic of discussion is method of constructing an analytic function. As earlier lecture we have done method of constructing analytic function, but today we are going to discuss Milne-Thomson's method. How can we construct analytic function using Milne-Thomson's method? The theory I have discussed in our WhatsApp group. And now today we are going to solve a question and we see how can we use method to solve a problem. So the problem which we are going to solve is if u equal to e to the power x, x cos y, y sin y this way, then find the analytic function u plus iv. So for finding the analytic function we must have u and v. U is a function of xy and v is also a function of xy. So let us solve by using Milne-Thomson's method. Now see the solution part. Here u equals to e to the power x, x cos y minus y sin y. Put this as equation number 1. As we know that ux equal to, by Cauchy-Riemann equation we have ux and vx which we have used in the previous method. But here in the Milne-Thomson method, we are going to find the partial differentiation of u with respect to x and again with respect to y. So first we have differentiate 1 partially with respect to x. So here we get the term as del u by del x equal to e to the power x. While differentiating this term, we have here e to the power x bracket x cos y minus y sin y plus. Now e to the power x taken outside. Now we are differentiating the term within the bracket. So we are having here x. So we get from here only cos y. So by solving this value we have equal to e to the power x bracket x cos y minus y sin y and then cos y here. Let this as phi 1. So I have given this function the name as phi 1 xy. See. Again differentiating 1 partially with respect to y. Okay. While differentiating with respect to y, we have del u by del y equal to e to the power x bracket x bracket minus sin y. While differentiating cos y, we are having here minus sin y. Then again we have minus. Since e to the power x has function of x, so we are not going to differentiate that one. So we only have to differentiate the term within the bracket. So e to the power x is taken the outside. And now we have the term here is now minus y cos y. Minus y sin y is differentiating, we're getting the cos y. So minus y cos y. And then since we have written here brackets, so write it here the plus sign. And then y1. So we have here only sin y. Now simplifying this bracket we have here equal to minus is taken outside. So minus e to the power x bracket x sin y plus y cos y plus sin y. And we say this function as equals to phi 2 xy. Okay. So here is our phi 2 xy. Okay. Now hence to find the analytic function by Milne-Thomson method, we use the formula f dash z equal to phi 1 z0 minus I phi 2 z0. Here we put x equals to y and we put y equals to 0 and we construct this formula. I have given this in the theory portion. Now this is equals to e to the power z phi 1 z0. So phi 1 xy here is it is. So while putting y equals to 0 we have here e to the power z. Then this function becomes z. Here is z minus 0 and then again we have 1. Okay. Here we get 1. So we are living with e to the power z, z plus 1 minus I. While substituting in the phi to z0, we have here it is phi to xy. So while putting y equals to 0, we are living with 0, 0 and again we have 0. So into 0. So we are having here f dash z equal to e to the power z bracket z plus 1. Let's put this equation as equation number 2. Now we integrating equation number 2. We get fz equal to integration of e to z plus 1 e to the power z into dz and plus 1 integration constant. Now this is equals to, while using integration by parts, we are having here z into e to the power z minus integration e to the power z into dz bracket plus e to the power z plus c. Now, on simplifying, we have here z into the power z minus e to the power z plus e to the power z plus c. Now, e to the power z and e to the power z getting cancelled. So, we are living with the function z e to the power z plus c. So, therefore, we have fz equal to z e to the power z plus c, and this is our required analytic function when we have given u equals to e to the power x, x cos y minus y sin y by Milne-Thomson method. I hope you all understand very well. If you have any doubt, then give me a comment in comment box. Thank you all.